So you look at aging just as a healthy process. It's not trying to be 18 forever. It's just trying to do everything you can to optimize the machine as we age. And so that's kind of the gist of anti-aging. I don't really like that term anti-aging. I prefer like healthy aging. But at any rate, that's kind of the idea of aging medicine, if you will, trying to keep people healthy as they age. That's the whole point.
Welcome to Mother Nature's Doctor, the podcast where ancient wisdom meets modern wellness. Hosted by Dr. April Schulte, a specialist in Chinese medicine, this show explores the power of nature as the ultimate healer. Each week, Dr. Schulte dives into a new health topic, revealing how holistic practices, herbal medicine, and time-tested natural remedies can help you live a healthier, more balanced life. Get ready to nourish your body, calm your mind, and reconnect with the wisdom of Mother Nature.
Hello, welcome to the Mother Nature's Doctor podcast. We are entering our fourth podcast already. I've had so much fun reaching out to all of you and hearing from you about some of your thoughts and concerns and different ideas regarding everything that Mother Nature certainly can do to help us heal. And I'm especially excited to have Dr. Scott Rollins with me for this episode of Mother Nature's Doctor. Dr. Rollins and I have known each other for quite some time professionally. We've worked together over 20 years now, sharing patients, different perspectives with one another. And I'm so excited to have you, Dr. Rollins. I'd like to give you a little introduction, if I may.
Thank you, April. It's good to be here. I always appreciate visiting with you.
Dr. Scott Rollins is a medical doctor who is board certified with the American Board of Family Practice and the American Board of Anti-Aging and Regenerative Medicine. He specializes in bioidentical hormone replacement for men and women, thyroid and adrenal disorders, fibromyalgia, and other complex medical conditions. He is the founder and medical director of the Integrative Medicine Center of Western Colorado and Beleza Laser Aesthetics. And you can certainly reach him at 970-456911 for an appointment, which of course we will include that information here for you as well. Dr. Rollins, how are you today?
I'm well. Thank you so much for having me. I've been looking forward to elaborating on some topic that might be of interest to you and your listeners.
Well, you and I briefly discussed possibilities for topics. And before we launch into that, I think it would be helpful for our listeners to understand what is anti-aging and regenerative medicine in general.
That's a great question. You know, the traditional allopathic training that we undergo is wonderful, and we learn all kinds of things about diseases that happen as we get older. But interestingly, we never really study so much the process of aging and things that we can do to optimize aging. And when you really start looking at that, it changes the paradigm a little bit because, so many things happen just with birthdays, Lord willing, and even if you do many things well to stay healthy, lifestyle things, still yet things happen with aging that you can't change, yet you can augment some things. And so things like hormone replacement or specific supplements that augment aging, for example, coenzyme Q is an enzyme that's essential for life, but around middle age, 50 or so, we quit making as much coenzyme Q. And so there's a logic to supplementing coenzyme Q and other things that just because of aging, it's kind of like putting premium oil in my 31-year-old Land Cruiser. It's going to run better. So you look at aging just as a healthy process. It's not trying to be 18 forever. It's just trying to do everything you can to optimize the machine as we age. And so that's kind of the gist of anti-aging. I don't really like that term anti-aging. I prefer like healthy aging. But at any rate, that's kind of the idea of aging medicine, if you will, trying to keep people healthy as they age. That's the whole point.
I never really thought about it quite like this until I asked you that question. I've actually never asked you that before. I think there's this general perception of aging as pathology, and there's a general assumption that with age, we're going to be sick. So now that I'm this age, I'm going to feel this way. And it's so empowering to know that actually you don't have to feel that way.
Well, that is so much the point. The point is that, it's really interesting if you study the aging process and you look at especially the genetic blueprint for humans. The genetic blueprint really there's two things that it's designed for. One, to live long enough to reproduce. I mean, that's kind of what we're designed for, honestly. Once we've accomplished that, our genetics aren't really designed for us to age to the extent that we do. And so things start coming apart at the seams, and you can do a lot to mitigate that. And that's the whole point of anti-aging is just to keep us as healthy as we can be. So when we get up into our 70s, 80s, even 90s, we're doing everything we can to keep things going well.
I talk a lot with my clients about how just because someone in our family history has a genetic, a genetic predisposition, if you will, to some sort of illness, that doesn't mean for sure you're going to get it. That's not necessarily something you have to get, that we can influence the genes in that way just by
Yeah.
things like you're mentioning, the
Yeah.
coenzyme Q and lifestyle, and even our emotions, our mental state, our environment, toxins, etc.
Well, you open up a couple of avenues of conversation on that, because two things. First of all, a lot of the genetics that we have aren't predestined. There are switches that turn certain genetic predispositions on or off. And there are genetic switches. This is epigenetics above the genome. There are things that you can do that turn on favorable genes and turn off unfavorable genes. And that's the whole science of epigenetics. And that has a lot to do with aging. And the beautiful thing there is you can study the details of the genetics and get all nerd on it. But at the same time, it's cool that so much of that comes back to lifestyle, diet, exercise, good sleep, managing stress. If you want to control your epigenetic switches, do those things well. But the second thing is you look at a whole different level of genetics, and that's gene mutations, things like ApoE mutations that predispose you to Alzheimer's, for example. Just as an example, just because you have that mutation doesn't mean that you can't step up the things that you can do to mitigate the risks of that. And it's very exciting. That's a great example of anti-aging. You look at ApoE mutations that increase your risk of Alzheimer's. Well, there's no medicines for that, but you can do a lot of things to mitigate that risk with plasmalogens and natural supplements, different things. There's a deep science to a lot of this stuff, but the point is that sometimes there are genetic mutations that they're not etched in stone. You can actually do a lot to mitigate that risk. So it's pretty exciting.
And then the beauty of science is learning. It's helpful to learn. If we do have that specific genetic mutation, then it can give us a little heads up to really pay
Yeah.
a little bit extra attention in that area.
Yep. Then you need to full court press to do things to mitigate that risk.
Here we are talking about genetics, and such a great segue into something you mentioned that you've been particularly interested in lately, which is microRNA. And I said, that's a perfect topic because I don't know anything about microRNA. So I would love to learn about that. And can you tell us what is that and how come you're interested and what are the benefits of knowing about it?
MicroRNA, I'll come at this straight on and then back up a little bit and give it more context how we use it. But first of all, microRNA treatments, what is that? And to understand that, you have to kind of step back and think about our DNA. So if you look at the DNA helix, the double-stranded DNA, everybody knows about that, I think. In that, we have 3 billion rungs on the ladder. Those are nucleotides. Those are that's the code of our DNA. And there are 3 billion, with a B, rungs of the ladder. And so when our DNA does what it does to create life, it unzips and creates code and then zips back together. And it's an amazing thing. And that's just how Mother Nature works. So when you talk about DNA, RNA, you're talking about a double strand versus a single strand of that code. So out of those 3 billion rungs of the ladder, you might unzip a couple of thousand of them for some mission, to make some protein, to build something, to give directions, whatever, in infinite capacity of our body. So RNA is a single strand and DNA is double. So When you look at messenger RNA in the body, that's when you slip off a single strand of DNA called RNA now. It's a single strand, and it has a message. That's messenger RNA. It has a message to tell your body to do something. And it goes out there to the factory and it creates more RNA and it goes forth and does what it does. So messenger RNA carries directions. MicroRNA is even smaller than that. And now let me give you an example outside of the body. When you looked at like the COVID vaccines were messenger RNA vaccines, and they were about 1,000 base pairs long. So again, your DNA's 3 billion. The COVID vaccine messenger RNA was about 1,000. It was only about 1,000, 1,200 or so.
Truly micro.
Well, that's not quite micro yet. It's
No,
still
yet?
it's still pretty big. That's messenger.
Okay.
That's messenger.
Oh, that's still messenger. Yeah.
It's two things. One, there's a message, and two, it's a little bit bigger. So about 1,000 base pairs, 1,200 base pairs.
Okay.
It's pretty big still, and there's a
Still big.
message there. So the
Okay.
COVID vaccines, just as an example, the COVID vaccines, they carried a message. They went out in the body and integrated with your DNA, and they told your body to do something. They told your body, they carried a message. They told your body to make spike protein, to do something. And that's messenger RNA. And some of the work that I do, in particular with cancer and with tick-borne and viral infections, involves microRNA. And micro implies that the base pairs, there's only about 20 to maybe 50 base pairs. So you're talking pretty small. Out of
That
3 billion in your DNA, 1,200 in a COVID vaccine, as an example, we're talking about 20, maybe 30 or 40 micro, very, very, very,
very,
very
very,
small.
very little.
And there's no message in it. There's no message. It's not it doesn't integrate with your DNA. It doesn't tell your body to do anything in particular at all. It doesn't match anything in your body. So microRNA is just a sequence of those base pairs that will go out and do something. And what they do, I'm kind of jumping ahead and I'll back up a little bit again to give this context, but what they do is they only bind with a very specific match, absolutely a lock and key. And so if there's 20 microRNA, if there's 20 base pairs of amino acids sequenced together, they will only match with something that matches it exactly. It's called antisense. It'd be like A and B matched together. They only match something that's the exact opposite, so to speak. And that's called antisense.
Okay.
So it's kind of like a lock and a key is the best analogy. It only fits if you find the exact key. So it doesn't carry a message. It doesn't intersperse with the human's DNA or anything like that. It only matches with the lock that fits the key. And in the
So is
context,
the lock the pathology when you're
Yes.
talking about
Yes.
actual therapy using
Yes,
microRNA?
exactly. So I kind of dived into the details of microRNA, which won't make much sense until I back up. Let me back up and kind of explain the context now of how we use that. So there are two main areas where we use it, and one is with circulating tumor cells that come from a primary cancer. The other area that we use this in is with very specific infections, notably most of the tick-borne infections, Lyme disease, Borrelia, Bartonella, Babesia, the various pathogens we find in tick-borne diseases, but also with a few viruses, Epstein-Barr and some of the herpes viruses, we use this microRNA technology with as a treatment. And specifically now talking about circulating tumor cells. This is a big topic, so we're going to kind of switch gears a little bit and come back to microRNA. When someone has a tumor, let's just say someone has a breast cancer. Let's say the breast cancer was found on a mammogram. It's maybe the size of a marble. It's localized as far as you can tell. Truth is, it's not entirely localized. Years before that cancer was ever found on a mammogram, literally years before, it already was releasing cells into the bloodstream, even when it was the size of a grain of rice, before it ever showed up on a mammogram or any other imaging test or whatever. Truth is, most cancers, breast cancer, colon, pancreas, so on, they are releasing cells into the bloodstream long before you ever even know you have a cancer.
And my understanding is theoretically, sorry to interrupt, but just theoretically, then, if our immune system is working optimally, it can already sort of kind of pick it out and
Well, yeah,
address it. That's
that's
the
how it
ideal world.
that's how it normally works, and that's how it works probably most of the time. You're absolutely correct. That's kind of a separate issue, but yeah, that's part of how your immune system normally controls cancer. I mean, this is a segue or a digression, but we have cancer in our body arguably all the time. We have abnormal cells, and either they self-implode, they self-implode, or the immune system recognizes them and takes them out. So that's true. But assuming it breaches those barriers and then you do get a cancer that's starting to develop despite those natural means to control it, it will start releasing cells into the bloodstream, and they're called circulating tumor cells. CTCs, circulating tumor cells. And we can draw your blood and we can identify those cells. And
That's
so
exciting.
it is. It's kind of a revolution in cancer treatment, but also in chronic infection and treatment as well. And so if you have these circulating tumor cells that are floating around, let me just continue that example. Let's just say you have a breast cancer. It's 1 centimeter and you have surgery and you have a lumpectomy and you remove the cancer. You remove the primary tumor. Now, they may look at the tissue on pathology under the microscope and not see any more cancer. You appear to have removed it all. And they may look at lymph nodes downstream and that you don't find any more cancer under the microscope, which is, looking under the microscope is a fairly crude way to look still yet. And you might do a PET scan and you might do blood serum markers and such, and you may find, okay, we don't find any more evidence of this primary tumor, this cancer. We don't find any more evidence of it. Well, that's not entirely true. We can still draw your blood, and most of the time, we will still find circulating tumor cells from that primary tumor. They are still there. And this is what happens, years later when you have a reoccurrence. Some of those circulating tumor cells have transitioned into circulating stem cells. They've decided, I think of them like seeds. They may or may not sprout. And some cancers, the odds are they're going to sprout, and other ones it's less likely they'll ever sprout. But they're there. The circulating tumor cells, they're there. And we can
Okay.
draw your blood and we can find them and we can get them. And once we get those circulating tumor cells, we can make treatments against them, and that's the microRNA treatment that we utilize.
So how is the microRNA administered to the system?
It's an amazing technology. So, first of all, the lab that I use is RGCC. It's Research Genetics Cancer Center. And they originally are from Greece, and they're also known as the Greek test colloquially. And they started, I think, about 2006 or so. And I started using them not too long after that. So I've been using this lab for a long, long time. And I know quite a bit about laboratories, but I'm not a lab rat, and I'm in awe of the technology of how they can do this. But I think from my study, they are one of the original labs and continue to be one of the best labs in the world at being able to do this. Can you imagine how you can draw someone's blood and take out every other cell except the cells that have markers for cancer? That's just amazing to me. But they can do this through a negative selection process and all kinds of high-tech stuff, how they can do this. So they can not only find the cancer cells, but they can keep them alive. It's phenomenal.
So how readily available are these therapies now in the United States?
They're not very readily available. There's some similar treatments that are happening in the realm of cancer, CAR T therapies and different things. So there are some similar therapies that are happening in the United States. And there are a lot of labs that are looking at circulating tumor cells. There are a lot of labs in the United States that will test you for circulating tumor cells. They use slightly different technologies. They don't necessarily keep the cells alive, but there's a flurry of activity in the world of oncology looking at circulating tumor cells here in the States. And I think in the United States, most of the interest is identifying genetic changes that happen in these circulating tumor cells that can help them choose better chemotherapy when there's a reoccurrence. But that said, once the lab identifies the circulating tumor cells, they can then find a very, very specific sequence of DNA to it's just as different as you and me, April. Our genetics are obviously slightly different, so that you are unique in the world, your genetics.
Right.
And
Right.
so if you have a cancer cell, it's going to be unique in the world as well.
That makes sense. I mean, I often think of us obviously as truly individualized beings, which is, it's fascinating, as we move smaller and smaller and looking at the body from a scientific standpoint, starting at the grander scale. Well, we are the species, we are human. And then we can kind of break us down when this is my arm and this is my thyroid gland and then these are my cells and then this is my DNA, and this is my RNA, and this is my messenger RNA, and this is my microRNA. That as we kind of delve deeper and more specific in looking at the system, that we see actually how individualized we truly are. So Western medicine, in a way, when we think about these technologies, is able to show the uniqueness of us. And yet, as a large whole, we still are treating clients and patients like they're all the same.
Well, yeah, and that's so true. And there's some absolute commonalities that we have, and some things that you can do some of the same treatments for everybody, and it's going to be beneficial for everybody. And yet you drill down to the DNA, and it's absolutely specific. Period. There's not another human on the planet that's exactly the same as you. So when you look at what the lab does is, they find these circulating tumor cells and they identify an area that's critical for cell survival. We know a lot about DNA, and we know a lot about certain patterns. Some areas do this, some areas do that. And so we understand quite a lot about small sections of our DNA and what those sections do. They allow the cell to make this protein, or they allow the cell to reproduce, or whatever those sections are. So the lab, knowing this, finds sequences, small sequences, unique to the circulating tumor cells or unique to the pathogen in the case of Lyme disease or something, and they make the mirror image, the antisense, the lock and key. They make the lock to the key that matches that sequence. That's what they make. So if they find a tumor cell or a pathogen like a Lyme bacteria, Borrelia, they find the specific 21 sequence, whatever, small micro sequence. They make the match to it, the lock to the key,
That's amazing.
the antisense, it's called. And that becomes the treatment. So they make a sequence of those microRNA chain, and that's what we give to the patient.
Where do they source the materials to make it?
That's a great question, and one that I don't entirely understand, but it involves the molecular biology and amino acids. It's really, on a chemical level, it's pretty darn simple, but from a technical level, it's incredible. And I would love to go visit the lab and learn more about exactly how they do this. It's kind of mind-blowing, but they make a sequence that matches exactly. And what that sequence does, you asked how we administer it. We administer it by an IV. So we draw your blood, and a month later, we get the microRNA and we give it to you through an IV infusion, and it drifts along through the body. It doesn't carry a message. It doesn't intercalate with your DNA. All it does is float along and bind to anything that matches perfectly, which is only your circulating tumor cells or only the DNA from the pathogen that we're treating, period. So if you gave the treatment to the wrong person, nothing would happen. It would be a very boring waste of money.
Right.
but we give it to the patient, and what that'll do, the treatment will simply float along and bind with the lock, will bind with the key, so to speak.
Even in my, yeah. Even in my medicine, I end up seeing people sort of once the disease process is really far, advanced. And so even a lot of people might consider complementary therapies toward the end. They've tried other things and they're not working. And while certainly that we can help in a lot of cases, Chinese medicine specifically is meant to be used preventively. And when we can see a person and find the imbalances, if you will, before an actual disease sets in or an illness sets in, then we're able to affect change. And so this conversation around microRNA technology has me wondering about the possibilities in preventive care. Imagine that's pretty exciting.
Well, yeah. I'm not sure to what extent you would use it. For example, if I don't have a cancer, and if I don't have an infection with Lyme disease or, Epstein-Barr virus or something, then there wouldn't be much utility for this type of treatment per se.
Because you have to find the actual evidence first so that you
Yeah.
can
Well,
see it
yeah.
out.
Yeah, in fact, it's kind of a separate, but a salient point. A lot of the testing, for example, with like Lyme disease, for example, a lot of the testing that we do are antibody tests, and they're prone to false positives and false negatives big time. And so it's not the best testing, but it's the best we have. And so at the lab that makes the microRNA, it's a reassurance to me as a practitioner that I'm not treating a false positive. Period. End of story. 100%. They cannot make the treatment if they do not find the DNA from your cancer or from the infection like Lyme disease. And so, from a practical standpoint, that's really changed my practice, especially with stuff like Lyme disease. So many times you test someone for Lyme disease and they test negative, but that's, as many as 50% of people that have chronic Lyme disease will test negative with standard antibody testing. It's woefully imperfect. And so you hate to embark on a ginormous treatment protocol, especially with antibiotics and all sorts of stuff, to treat someone for Lyme when you're not even 100% sure they have it. That's not cool. And so one of the things about this microRNA treatment that reassures me as a clinician is that if I order this treatment, it can't be made if they don't find the DNA from the pathogen. They have to find the DNA from the
Right.
pathogen. So there's 100% reassurance that, yes, they have this pathogen in their body, or they couldn't make the treatment
They
otherwise.
couldn't make the treatment.
Yeah,
They wouldn't.
exactly. Exactly. Maybe for prevention, well, this opens up a big can of worms. You start looking at this technology for screening tests. You or I, April, you or I tomorrow, we could go to my office and have our blood drawn and see if they find any circulating tumor cells. We could find cancer cells in our body years before we ever find it on a
But that
mammogram.
wouldn't be enough for this lab to find the lock.
It would. Sure, it would. It would. I'm
So
just
then in
saying,
that case, it could be.
this whole technology is already being used as screening. You're seeing it already in different labs in America. Gallery and different labs are using similar type testing. They're not necessarily, some of them are looking for DNA specific to cancer, some of markers specific to cancer, some are looking at protein fragments that are specific to cancer. There are some labs now in the US where I can draw your blood, and I've done it a few times as a screening test, look for like DNA fragments from like 50 different kinds of cancer. So this same technology, I've used it a few times in this context. I can draw your blood and tell you whether or not there's evidence of a breast cancer, colon cancer, prostate cancer in your body. Now, you may go to the conventional doctor and do scans and mammograms and blood tests and not find any evidence of it because it's the
It's not big
primary.
enough yet.
Exactly. The primary tumor's not big enough yet. And so this opens up a real can of worms, though, ethically, because what if I drew your blood tomorrow, April, and I found evidence of a circulating tumor cell? Well, that circulating tumor cell, it may or may not ever sprout. It may or may not ever develop into a full-blown primary tumor that you diagnose as, quote, cancer. So technically, you might give people reason to worry that they don't need to.
Eh,
Your body might ultimately be able to turn that around.
You bring up an excellent point. It's fascinating. And from my side, clinically, one thing I notice all the time, let's take the conversation a little bit away from genetics and something much bigger like a hip joint. And I could have someone come in with chronic hip pain and we're able to get it to go away. And we're able to even restore function in the hip. The pain is a lot less. And then the patient turns around and goes ahead and has an imaging study. And they see in the imaging study, they're bone on bone, or maybe they have a torn labrum or something like that. And guess what? Their pain comes rushing back. They need surgery. And
yeah,
so I've
yeah.
seen that time and time again.
Yeah.
It does speak in such a great way to sort of kind of leave this edition of the podcast in the way of thinking that certainly we have so much behind us to help empower our health, in all the way down to microRNA testing and then all the way as big as our mindset.
Yeah, well, that's a great general point. I've had patients over the years who don't want to do any screening tests because psychologically they felt like it would be a harbinger or they would bring on the disease. And it's like, well, I get that. But at the same time, it's like, well, wouldn't you want to know if you had something? Wouldn't you want to know if you had signs of insulin resistance and metabolic dysfunction years before you formally got diagnosed with diabetes? I mean, it's so much easier to turn it around
Be proactive
the earlier
to get
you
ahead of
find
it.
it. And so you got to find a good psychological balance of that kind of thing. And I'm careful with that in practice. I mean, you can screen people and give them all sorts of worries and concerns that are unnecessary. And at the same time, those same things can be early indicators that give them a chance to turn it around. So
Absolutely.
there's
Information
a
is
balance to
power.
that. Information's power. And that's where, as a practitioner, it's important to understand, where people are at and psychologically what they want to know. I mean, they're in charge. What do they want to know? Are they the type of person who doesn't want to know these things? Or they're the type of person that does? And, we can do a lot of early screening. I mean, even in conventional medicine, I have a lot of patients who will not do mammograms, colonoscopies, any of that kind of stuff. And I have other patients who want to do that, more than necessary. And so a lot of that's, kind of psychological, what's the patient wanting to do and where they coming from. And that's cool. You want to always meet people where they're at.
Absolutely.
Your job and my job is to help give them context to that and help them wherever they're at in their journey. So I'm a fan of rational early screening if it can help you identify things that can help you turn health problems around before they ever get started.
Absolutely. And then empowering ourselves as patients, and then for us clinicians with our clients to understand there are so many different tools available from all different aspects of our health. And it's so beneficial to integrate care.
Yeah.
And bring our minds together. I can tell you I've been very appreciative of having you to lean on at times when I've needed or could use a different perspective. And I was feeling stuck on a patient, for example, and you've been able to help me, guide me in a direction that could help that client. That's just invaluable. So I'm appreciative of you continuously.
Thank you. Well, right back at you. I referred a couple people to you for help in the last week or two.
Yes, that's fantastic. Thank you.
you.
And I know I've actually would like after our podcast at some point to sit down and chat with you about a couple of clients as well. And to our listeners, thank you so much for joining us. And you can find Dr. Scott Rollins at the Integrative Medicine Center of Western Colorado. Phone number is 970-245-6911. or at imcwc.com. Thank you so much, Dr. Rollins. Hope you have a lovely evening.
Thank you, April. As always, it's a pleasure. Take care.
All right. We'll connect soon. Bye-bye.
Bye-bye.